Alright guys, in this last video today I'm going to be looking at 3 inequalities, compound inequalities. We're going to be trying to solve all of them, alright? So let's go ahead straight into it. We've done one of these already. This is an and, right? We've got everything together. There's a whole one statement, but it holds 2 different pieces of information. So we've got to break it into the 2 pieces. We've got one that's going to be 3 is greater than or equal to negative 2x plus 5. And then I'm going to have another one, which is going to be the other half right here. So negative 2x plus 5 is greater than or equal to negative 6. Okay, so now I'm going to solve each of these. I'm going to go through this a little bit quickly because you should be able to do this by now. I'm going to subtract 5 from each side. Have negative 2 is greater than or equal to negative 2x. I'm going to divide by negative 2. What? I'm divide by negative? Divide by negative. Well, we've got to switch the sign around, so we're going to switch the sign around. So that's going to be 1 is less than or equal to x. We had to switch the sign because we divided by a negative. Here we go. Let's do the other one. We're going to subtract 5 on this side. I got negative 2x is greater than or equal to, negative 11. I'm going to divide by a negative 2. What happens because I divide by a negative? Got to switch the sign. Those cancel out. I've got x is less than or equal to because I divide by a negative. And then negative by a negative is positive. So that's an 11. But me, I want to get a fraction. I don't like the fraction. I don't care. Do the fraction. All right, here we go. Put it on a number line. We got a 0, we got a 1, we got 11 over 2. It doesn't really matter what that is, but it's bigger than 1. So there it is on our number line. Okay, so the first one, x is greater than or equal to 1. So that would look something like this. And then we'll do the other one, x is less than or equal to 11 over 2. Now remember, and, this is an and. We know it's an and because it was all written together. So this is an and. An and means that we're looking for the place where both of the equations work, where they're both solutions. And so that means everywhere from 1, because 1's included in both of these, and then everything all the way up to 11 over 2, just like this. And so that would include, that would be a solution because it would be somewhere in between. All right, let's move on to the next one. We got to get rolling. We only got 3 minutes left. Okay, here we go. This one is an or. Okay, so an or. We've got 2 different pieces now, so let's go ahead and just solve this piece. We'll go subtract 1. So a is less than 3. And then we'll do the other side. We'll add 1 to each of those. And we've got a is greater than or equal to 4. And so now we'll go ahead and put that on our number line. I've got a 0, I've got a 3, and I got a 4. Okay, so the red one is saying that a has to be less than 3. Open dot that way. Okay, and then the blue one is saying that a is greater than or equal to 4. So there you go. Going towards the positive direction. I always do my work above and below, and then I put the final answer on the line. Otherwise, you may be putting things on the line that you don't need. Now remember, or means that anywhere where one of these lines is a solution, we want to count it, even if both of them are a solution. So here, we've got a solution that goes from positive 3, but then to the left. Okay, so all of these numbers are solutions. And then we want positive 4. A is greater than or equal to 4. So we're going to fill in the 4, and then we're going to go greater than that. All right, so there we go. We've successfully put all of the answers. Every single number in all of this shaded line will be true either in this or in that. Okay, let's move along to the last one. Man, we're cruising. But we got 1 minute and 15 seconds left. We better go fast. We better go fast. Fast, fast, fast. Not that fast. Okay, here we go. First, this one, we're going to subtract 7 from both sides. I've got negative 2m less than or equal to 6 divided by negative 2. Divide by a negative. We got to divide by negative. We got to switch the sign. So m is greater than or equal to negative 3. Let's go on. Going to subtract a 12 here. We've got 5m is greater than 25. We're going to divide by 5, and we've got m is greater than 5. So here we go. We're going to finish this up, put it on a number line. This is an or. Remember, this is an or. So we've got negative 3, we've got 0, we've got 5. This one right here is showing that m is greater than or equal to negative 3, so that's a solid dot going greater from there. This is m is greater than 5, so that's a solid dot going greater. We want or, so we want all the places that work in this one or that one. So I got to include the negative 3. Oh, sorry, this one should be an open dot. Don't forget that, Mitibawara. Okay, and then we're going to go in this direction. Go, 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 go. We're going to include everything because all of those work in at least one of those two